Right. Recorder is started. Double checking, make sure it's recording the audio too. Yeah. Hey.
Is this what you were talking about? A travel droid like
Yep.
this? Yeah, something like
I like that. It looks like an eraser.
yeah, something like this.
Yep.
Okay.
So we can talk about that first. Okay, you know how to set up a live distribution, and use that to. I thought I turned on the projector. Obviously, that was not the case. And there we go. And I'm gonna use the microphone today. It's gonna be a mixed thing because I can't really speak as loud as usual. I don't really speak loud anyway, but today's gonna be softer because I have a cough. But the recorder is gonna be able to record the cough a lot better with the mic. So it's kind of like, well. Okay. All right, so I don't know about you guys, would you mind if I turn off this light too?
Oh, that's better.
That's better, right?
Yeah. Fine by me.
Yeah, and I think the blinds can be arranged a little better too to kind of block some of the outside light, because right now a lot of light is bleeding through the blinds. It's really tempting for me to go buy like cans of spray paint. Just go just paint the whole thing. This building is going down in a year, okay? So it's not like
just say that when they ask you about it. Yeah.
well, I'll give them the bill. I'll give them the invoice. It's like, okay, I would like you to pay for the paint too. In the police department, if you guys want to help me paint, that's good too. You can make it tactical black if you want. All right, so getting started with Java, this is basically where we are currently at. We are kind of merging some of these sections into one right now because we are talking about all of these things. With inheritance, the concept of classes, members, and stuff like that. So when you click on getting started with Java, we have two modules at this point, and one homework assignment. And part of today's lecture is to set up a live distribution so that at least in class you can make use of the live distribution. So while I'm teaching the class, or I can do it during the lab time as well, I can help you guys set up the first one, which is where the image is going to be. Okay? You can do that yourselves, okay, but not on these computers. Okay, so I really want to help you set up so that at least by the end of today's class you can use these computers for homework assignments. So the one program that you need to use in order to burn the ISO image onto a USB thumb drive is you cannot just write the ISO file as a file on your thumb drive. That won't work. What you need to do is to get a Win32 disk imager, which is something that I searched for last time. So this is a program, and I have used it before, and I verified that this works. Okay, this is from SourceForge. Yep, it still runs SourceForge. Very simple program. You run it, and if you plug in a USB thumb drive, it will appear over here. This is device. Okay, it spells out device here, and if you click here, it will show only thumb drives. So you won't accidentally overwrite your internal hard drive because your internal hard drive won't show up here. So the key is only to have one USB thumb drive attached, and that's the one that you want to overwrite with the image. On this side, you specify the ISO file, which is the CD-ROM file or DVD-ROM file, which you can download from my shared drive. So once you specify the ISO file and also your thumb drive, on this side, you just click write or install. This is right here. So you just click write, and it will overwrite the drive itself with the ISO image. And the ISO image that I prepare can be booted. So all you need to do then is to plug in your thumb drive, and restart your computer. You might have to do a few things to make sure that your computer can boot from a USB thumb drive. That depends on the brand of the computer as well as the model. If your computer is set up to EFI booting, then you might have some extra issues, and we'll try to address those issues as they pop up. Are there any questions at this point? If you have a newer computer, okay, chances are you're probably booting using EFI or UEFI, and as a result, this approach may not work. So in that case, you will have to, we'll work out something else that will work. So getting back to the class, I think I shared a folder already, so let me double check on that. So 363. This is the shared folder for my Debian images, which is something that you can also click on. So I uploaded a few more files, in addition to what was already here on Monday. So we still have all of these folders. The latest image was built or burned on the 16th of this month, so about a week ago. But I also uploaded some of the shell scripts. So these are the files that I can use to prepare a drive for several things. One is if you have let's say a terabyte external hard drive, these ways will allow you to have other partitions. So in other words, for this class, if you just say, well, for this class I only need 200 gigs, okay? But I want the other 800 gigs for my other classes. Well, you can do it, okay, using these scripts. I'll show you one. I'll show you one script here, and let's see if I can open it. Open with Notepad. Okay. Somewhere else. There we go. So these are the commands that I can run in Linux in order to prepare your drive so that you can make use of your drive for this class, for booting into Linux and using the persistence and all that good stuff, and still have some left, for something else that you want to do. Okay, it's a little bit complicated because you have to prepare the GPT. I think it's the something partition table. It's a standard based on EFI, so you have to have the tools to do this. And I have used this to prepare my own drive. What I'm using right now, and it works. There's only one caveat with this approach. The one caveat with this approach is if you plug in your external hard drive to an older PC running Windows that is not EFI compatible, those partitions would not be readable anymore. But newer computers, which are EFI compliant, should be able to read everything on the drive. Okay, so we have some trade-offs. Okay, so we'll do it the simple way first. If it works, then it's okay. If it doesn't work, then we'll go figure out the more complicated ways to do things. Okay. All right. So does someone want to be my guinea pig today? Give me your 4 gig drive so I can use yours to try out the approach. Okay, so we'll use yours first. Okay, and I can just do it all in sequence. Okay. This one looks kind of funny because it looks like an eraser. which also makes it can be lost, just like an eraser.
Does it actually erase?
No.
I don't think so, but it certainly has the texture of an eraser. But it's also bigger than most USB thumb drives, so putting it in may take up more space than some of the other options. Okay, all right. So this is what I do in Linux. The first thing is I check. Oops. Oh. So the first thing I do is I check, what is the latest drive that I plugged in, because the worst thing that can happen is I overwrite a drive that is not the one that is intended to be overwritten. That would be the worst scenario. Okay, so I can now see that SDC is the drive that I just plugged in because it is the latest one to be recognized.
What was the command that you did? Yeah.
It's a DMESG in Linux. So all of these commands would only run in Linux. All right, so the first thing I need to do is to find out where's my own ISO, and I think it's listed under live mount, probably overlay. Nope, I guess not. Root FS, nope. Medium, okay, possibly. Okay. So instead of searching it for it, by hand, I'm just gonna look for it using a command. So I found the command here, or I found the location. So this is the location to the ISO file, which is on my own external hard drive. So the command to burn the ISO file onto an external USB drive is super easy in Linux, okay, which also makes it super dangerous, because if I type something wrong, I could be overwriting and killing another drive. Because
how to do it not in Linux?
Yes, you can do it not in Linux by using a Windows tool called Win32 Disk Imager. So if you download this tool and install it, you can do it in Windows as well, but not on these computers, because these computers are locked down. You need administrative access to run this program. Okay, so that's why if you want to get it done today, I can do it on my computer, and once we do it on a few computers, then we can do it to the rest of the computers. So we have mount, /mount, persistence, SDA3, Debian, that's the install file. This is the ISO file. OF stands for output file, so this is where I need to be careful because it has to refer to the drive that I want to overwrite. And BS is block size. I can use 4K, 4 kilobytes, and that's it. Press the enter key, and this will overwrite the drive with the ISO image. So depending on the speed of your drive, this may take about 10 minutes. So we'll just let it bake for the time being, just like all those, as seen on TV, advertisements. We'll start baking, and then we'll come back and check on it later. Yep.
Are all my files going to be okay? I'm just
They were okay. But this process destroys the entire drive. Okay, so nothing is left on that drive. Okay, so now that this is underway, we'll go ahead and do something else with this class. And let me close the tabs that I don't really need. I probably should use one profile per class, so that way it's easier to stay focused and not have to do this every single time. There we go. Okay, so last time we took a look at a Java program, which is this particular module, 254. And did anyone try this approach? Download the zip file, unzip it, and then just have Android Studio to point to the unzipped folder and be able to open up the project. Yep. Did you try that?
Yeah, I tried it.
Did it work?
It worked, yeah, kind of.
Kind of. What did not work?
I didn't get the certain features, the first features you talked about, the very first, there's under app manifest, I couldn't find manifest, I couldn't find any of that.
Okay, all right. So what I'll do is I'm going to try this approach myself, here. So I'm going to download this file first. Okay, so click on it. Should have right click, so I don't have to go back. That's okay. So click download. So that will download this file. This one can go back. And I'll just save the file to my temp folder. There's no need to put it into my downloads folder, so I'm going to put it into my temp folder. And it's already done, because even though it's 24 megabytes, the network connection here to the Google Drive of the school is actually really fast. So it's already done downloading. So I switch to a command line, open a new tab here, and go to the temp folder, and just go ahead and unzip the file. So let's check all the zip files. I probably don't want to do it over here, so I'm going to go to my home folder, which is on my persistence drive. Okay, we'll talk about how to create a persistent drive in just a little bit. And I'll make a test folder. Okay, there's a test folder already. Okay. So we'll create a test folder. In the test folder, we'll unzip that file. So this file is called, let's see, what's the name of that? First shell app. There we go. So the unzip will just unzip all the files, and the next thing we'll do is to start up Android Studio. So we go for Android Studio bin studio.sh. This is what you need to do in Linux, but in Windows you don't have to do this. Yep.
Also, I had like a rendering issue.
Okay.
It was some kind of rendering issue, but I was able to analyze the code though along with the paper.
Okay. So the rendering of the preview of the screen, something did not work. Okay. All right, so I'm starting up Android Studio right now. And do you think it's going to need an update today? Yes. I just updated this on Monday. I'm pretty sure I did. And this is why we cannot install Android Studio on these computers, because if they're deep frozen, we are locked down to whatever version is available at the beginning of a semester. It's not going to stay updated. Okay? So in this case, I can either do it now or I can do it later. Let's go ahead and do it later. Okay? So what I'll do is I'm going to close this project. Okay? So let's close this project. So I'm going to open a new project, but the new project is not located where the projects usually go. It is now in the test folder. So I'm going to start a new, open an existing Android Studio project, but this time it is in the user home folder, but it's under the test subfolder. So I look into the test subfolder, and you can kind of see, I'm not sure how much you can see, but once we open up the subfolder test, the icon of first shell app is different, okay? Because it automatically recognizes the components that are necessary as an Android Studio project. So it automatically says, hey, this is something that we can just open as a project. So we'll go ahead and select that, just like that, and then click OK and say that this is the folder where I want to open as a project. And it says, Android SDK does not belong to a directory. Android Studio will use this. Android Studio will use this Android SDK instead. Okay. And we'll modify the project's local property files. Okay, so that's fine, okay, because it's just complaining about the location of the SDK. But it will still open the project.
Did you double check your recording today?
I thought I did. Yep, so it's good. And because I built this project on a different computer, so it understands that some of the build tools are not there. So it automatically suggests that I have to download and install this particular build. It's just basically a different version of the SDK tools. So now we have installed whatever is necessary, and the project should open up. Okay. Gradle is still working, so I'm not gonna do anything until it's done. And this is working off of an external hard drive, and you can see how fast it goes. Okay, it's almost as fast as an internal hard drive. Now it's all done. We go to first shell app, and you can see under apps, okay, there we go. That part is a little slow. Uh-oh. Something just happened. Okay, so it just froze for a moment. I don't know exactly why. Okay, so we can go to source, and it froze again. The recorder is still on, it's still recording, and this is the recorder itself is taking 16% of the CPU time doing the transcoding. Okay, let's do this one more time. Apps, source, Android test, and now we can go to, oh, I think I picked the wrong one. Main is the correct one. And then we can go to either the Android manifest. So that's the manifest file. It's down to this level. We can also go to the resource where we will find the layout, or we can go to Java to find all the source files. So if we go to the Java, I only got one source file here for main activity, and now we get all the code, the same code in the notes. Is that okay? All right. So I just want to double check that the process itself does work. Okay, so this way I can publish, test code, and you guys can just download the test code and be able to not only read it, but to play with it too. Okay. All right.
When you open that, did you just use open? You didn't use an import, right?
Say that one more time.
When you open the project, you just used open.
Yeah. When I open the project, this is what I did. So I'm going to close it again, because the second time I open it is going to be a lot faster. So what I did was to use this link here, which is open an existing Android Studio project, and I just need to specify where to open it.
Okay, because I've seen sometimes they use import project.
Yeah, the import only works for the earlier versions, non-Android Studio stuff. So if you had a really old project from the Eclipse days, that you want to use the import. I'm not sure about the Android code sample, what that does. That might be something that is from the web itself, if I click this. So this is, just giving you a choice of, the sample projects that are available through Android Studio. So these are basically pre-done stuff, which is great. Okay, if you want to learn something about, how do I set up sample TV channel app, this is a great way to do it, because it just imports the project directly from the web and have it installed locally on your computer so you can play with it. But that's not what we were doing. We were just opening an existing Android Studio project from a specific folder. Okay? So now that we are done with this, we can go back to the same thing, and you can see how fast it opens up this time, because everything is already done. Gradle is all updated, so it's all good. Okay. So are there any questions at this point about what we have done so far? Here's the code, and the actual code is here. Okay, so this is actually generated. For the most part, this program is generated. This portion is completely generated by Android Studio. Okay, and we explained on Monday what is at override. At override is not necessary. In other words, if you delete this line, the program will still compile. It will give you a warning, but it will still compile. At override is really just a feature for the compiler to double check for you. Because when you say add override and then your protected void on create blah 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 blah, you are telling the compiler that the superclass, in this case the superclass is app-compat activity, is supposed to have its own onCreate method, and you are overriding the method of the superclass. Okay? Now if you take out add override and you have a misspelling here, instead of an uppercase C, you type a lowercase c, then if you don't have add override, the compiler would just say, okay, it's okay to define a new method called onCreate with a lowercase c. I don't have a problem with that. Except that will no longer be, it won't be related to onCreate anymore. You can specify whatever code you want with onCreate with a lowercase c. It's just not going to get called in any way, but the code is there. But in the case of add override, now it complains and say, hey, whatever you're overriding does not exist in the superclass. Maybe you misspelled something. So that's why add override is useful, because it makes the compiler check certain things for you. Is that okay so far? Okay. Okay. So the only handler that we added is click handler, which is a small subroutine or method where we have a label and we find the label using find view by ID. This is a method of an activity class, and we locate the label using its ID. The ID, which is basically just an integer, is defined as r.id.helloLabel. R itself is a class. ID is an embedded class of R, and then helloLabel is what we call a static constant inside that class definition, which basically means you can refer to that without having to create an object first. Okay? So basically just look at this as a constant. Okay? And whatever this returns, okay, find view by ID always returns a reference to a view object. I can downcast it to a text view, so I can change the text of that particular view to yo, what's up? Yep.
What do you mean by a view object?
A view object is an object of class view. So the view class is something that we're going to take a look at today. To be more specific, we want to see, but how else can we set a listener for a particular event, or how do we set up an event handler? Okay, because this is one way to do it. Okay, so the second question, okay, let me see if you guys can remember. How did we link the button, which is in the layout, to be associated with click handler, which is what is being called when we click on that particular button? How is that link done?
The label? The hello label? Or the
No?
address?
Well, the hello label is only associated with a text label that I'm changing, right? But what about the button? The button has to be connected to click handler somehow. It's one of the attributes. Very good. But where is that attribute? It's in the property of the button in the layout editor. Okay, very good. So let's go ahead and find that. Okay, so we go to source. It's an XML. It is a part of the XML document. So we go to. It should still be apps and source. Android test. How do I get to the XML file?
I think it's a main.
There we go. Thank you. It's a part of the resource, and the layout is here. So there we go. So when we click on the button, okay, let me zoom in a little bit so we can actually specify which one we are clicking on. So we're clicking on the button itself. As a property of the button in the layout view, the property onClick specifies the name of the method of the activity that is containing it. So this is how we link the button and say, okay, when this button is clicked, go ahead and call that subroutine, call that method, called click handler that is defined in the activity itself. Okay? So, but this is it's kind of good in a way because it's easy to specify, but it's kind of bad in a way because it's very static. I cannot change this after I compile the program. After this becomes a package, I cannot associate a different event handler to a button anymore.
To this button.
To this button.
Okay.
But sometimes you create new buttons. You create new user interface elements as you execute the app. So this method won't work with those particular programs because if you have a list view, inside a list view, each row can have multiple things that you can click on. This approach won't work. Will not work with that because you're generating things on the fly. Okay. So one of the things we'll do today is to figure out how do we associate a event handler or event listener to a particular thing so that we can change that on the fly anytime we want to in Java code. In other words, we'll say, okay, what if this is not here? Can we still do something to get it done? Can we still specify what to do or what needs to execute when this button is clicked? That would be one of the